Hi students and friends, welcome to the channel Learn and Teach by Ayaz. I will continue my video lesson for the topic acids, bases and salts. So let's begin the video lesson with the learning outcomes of this lesson. Describe acids and alkalis in terms of their effects on litmus, thermophthalene, methyl orange. Define a strong acid as an acid that is completely dissociated in aqueous solution, and a weak acid as an acid that is partially dissociated in aqueous solution. State examples of strong acids, including hydrochloric acid, nitric acid, and sulfuric acid, and construct these symbol equations to show their complete dissociation. Here's an example. HCl gives H positive plus Cl negative ion. State examples of weak acids, including carboxylic acids, and construct the symbol equations to show their partial dissociations. For example, for ethanoic acid, CH3COOH is the formula for ethanoic acid. It will dissociate to give H positive ion and CH3COO ion. Describe how to compare hydrogen ion concentration, neutrality, relative acidity, and relative alkalinity in terms of color and pH using universal indicator paper. What are indicators? Indicators are dyes which change color when acids and bases are added. A universal indicator gives different colors in strong and weak acids and alkalis. In case of universal indicators, we'll compare the color with the color on indicator color charge. Compare the color with color on indicator paper chart. Color of different indicators in acidic and alkaline solutions. So first indicator is litmus paper. You can also have litmus solution. In case of acidic solution, it will turn to pink or red. For alkaline solution, it will turn to blue. Thermophthalene gives colorless solution for acids and blue for alkaline solutions. Methyl orange gives red color in acidic solution and yellow in alkaline solution. Bromothymol blue gives yellow in acidic solution, blue in alkaline solution. You have to learn this table. It will help you in solving questions in paper 4 as well as in paper 1 and paper 2. Learn these change in colors. Strong acids dissociate or ionizes completely in an aqueous solution. Now, what do you mean by dissociation or ionization? Dissociate or ionize means splitting up. So acids split up or break up in an aqueous solution completely. We are talking about strong acids. Now, these strong acids act as strong electrolytes. Their pH value ranges between 0 and 3. It includes all mineral acids. Some examples of strong acids are hydrochloric acid. You know the formula, which is HCl, nitric acid, which is HNO3, sulfuric acid, which is H2SO4, phosphoric acid, it is H3PO4. There are some other examples of strong acid like perchloric acid, which is HClO4. HClO4 is perchloric acid. Like strong acids, strong alkalis also dissociate or ionize completely in an aqueous solution. They also act as strong electrolytes. The pH value ranges between 11 and 14. Some examples of strong alkalis are sodium hydroxide, NaOH, potassium hydroxide, KOH, calcium hydroxide, CaOH whole twice, strontium hydroxide, SROH whole twice. Now, weak acids and alkalis, they are opposite to strong acids and strong alkalis. They dissociate or ionize incompletely or partly or partially in an aqueous solution. They do not dissociate or split up completely. The reason is that the ions recombine to produce a molecule of acids and alkali. These acts as weak electrolytes. The pH values for weak acids ranges between 3 and 7, but the pH value for weak alkalis ranges between 7 and 11. So some examples of weak acids. Acetic acid, it's an organic acid. The formula will be CH2COOH. What are organic acids? Organic acids are organic compounds. Organic acid is an organic compound. And what are organic compounds? Organic compounds are those compounds which contain carbon as an essential elements. Contain carbon as an essential element. Now, this acid is very familiar to you, carbonic acid. You have these acids in soft drinks. When carbon dioxide reacts with water, it produces this acid. So formula will be H2CO3. Formic acid, formula is HCOOH. Formic acid, the word formic comes from Latin word formica, which means ants. Comes from Latin formica. The bite of ants contain this acid. Nitrous acid is HNO2. Some examples of weak alkalis. Ammonia. The formula for ammonia is NH3. Remember, ammonia acts as alkali in water because in water it will produce OH negative or hydroxyl ion, which is very important to show the alkalinity of alkalis. Methylamine. The formula will be CH3NH2. Simple equation to show the complete dissociation of strong acids in an aqueous solution. I'm giving you example for the complete dissociation of hydrochloric acid and sulfuric acid. For hydrochloric acid, you will start with HCl. You will either write HCl aqueous or HCl gas plus H2O liquid. On complete dissociation, it will give you H positive ion in aqueous solution plus Cl negative ion. Similarly, you can write or construct the complete dissociation for H2SO4, which is sulfuric acid. H2SO4. Dissociation occurs between these two. You will not get H2, you will get H positive ion. You have two H here, so you write 2H positive ion. And the other will be sulfate ion. You know the charge on sulfate ion, which is -2. So this will be the complete dissociation for sulfuric acid. Now let's do this for strong alkalis like NaOH, sodium hydroxide. NaOH aqueous, it will produce Na positive aqueous plus OH negative aqueous. In the same way, you can construct the ionic equation for other strong acids and strong alkalis. Now let's construct the equation to show the partial dissociation in weak acids and weak alkalis. For weak acid, I have taken ethanoic acid, CH3COOH. Now, in this case, you have to show reversible sign because the ions produce rejoin or recombine to give the molecule of acid. And in case of acid, the dissociation will be from this side for organic acid. And you will get what? You will get CH3, COO minus aqueous plus H positive aqueous. For carbonic acid, the ionic equation will be like this for partial dissociation of carbonic acid. This is carbonic acid. Again, you have two hydrogen. So you write 2H positive ion, 2H positive aqueous plus CO3. You know the charge on CO3 carbonate ion, which is -2. Now I'm showing the incomplete dissociation for ammonium hydroxide or ammonia in water, weak alkali. Ammonia in water. So you write NH3 gas plus H2O liquid, NH4 positive plus OH negative aqueous. Use of universal indicator paper. Now it's a full range indicator. It's a full range indicator. Used to show relative acidity and relative alkalinity in terms of color and pH. Then in the end, we will compare the color. Compare the color with color on indicator color charts. Describe how you could measure the pH of acid and alkali solution. It's very easy. For this purpose, we use pH meter. pH meter is an instrument used to measure the pH of an acid. For acid, the pH will be between 0 to 7. For alkali, it should be between 7 to 14. 7 is neutral. Thanks for watching. Press like, give comments, and share my videos. For more videos, subscribe to my channel and press the bell icon.